Hello everyone. Now let us study about the galvanic cell or voltaic cell. In the last class also we have studied about galvanic cell or voltaic cell, the functioning of galvanic cell or voltaic cell, how it works and what is the effect of external potential on the galvanic cell. Okay, so now once again I will define galvanic cell. What do you mean by galvanic cell? A galvanic cell is an electrochemical cell which converts the chemical energy of a spontaneous redox reaction into electrical energy. So that electrical energy is used for some purposes. Okay, so this is the experimental setup for Daniell cell. Experimental setup for Daniell cell. It consists of two electrodes. Two electrodes are connected by externally connected by electrical wire, conducting wire, and they are internally connected by using a salt bridge. So the anode is made up of zinc electrode and the cathode is made up of copper electrode. If a galvanic cell is said to be Daniell cell, actually the Daniell cell is the earliest example of galvanic cell. If a cell is said to be Daniell cell, there is a condition. That condition is none other than the concentration of zinc ion solution must be 1 molar and the concentration of copper ion solution must be 1 molar. Then this cell is called as Daniell cell, the galvanic cell in which the concentration of electrolytes is equal to unity or 1 molar, then the cell is called as Daniell cell. In the last class we have discussed about the functioning of Daniell cell. At zinc electrode oxidation takes place, so zinc electrode means anode, oxidation takes place, and at cathode reduction takes place. The overall reaction for this is, I will write the reaction for this cell is here Zn plus Cu2 plus in the aqueous solution form gives Zn2 plus Cu. So actually what this chemical reaction indicates, see the chemical reaction, zinc is metal, the metal is converted into metal ions, means zinc is dissolved and the dissolved copper, the copper ions which are present in the solution, they are deposited on the copper electrode. So this reaction is not a single reaction but it is a combination of two type of reaction. In this reaction there are two reactions. So here the first one I will write the reaction of zinc. At anode there is zinc electrode is oxidized. At anode which reaction takes place? Oxidation. The zinc electrode is oxidized, and at cathode the copper is there, the copper is reduced. The reduction reaction takes place at the cathode. I'm sorry. So here at anode the chemical reaction taking place at anode is here zinc is oxidized to give Zn2 plus ions and 2 electrons, and at cathode the chemical reaction is said to be reduction reaction where Cu2 plus ions gets 2 electrons, they are converted into copper atoms. The ions are converted into copper atoms. Here the zinc atoms are converted into zinc ions. Now see the chemical reaction carefully. This reaction is oxidation reaction. At anode there exists oxidation reaction that takes place is a oxidation reaction, and here it is reduction reaction. Actually these two reactions are not complete reactions but these two are half reactions. So we will call this reaction as oxidation half reaction. So we can call the first reaction as oxidation half reaction. We call this reaction as oxidation half reaction. Oxidation half reaction, and this reaction is, what is this? This is reduction half reaction. Reduction half reaction. See here the oxidation half reaction takes place at anode and the reduction half reaction takes place at the cathode. The combination of these two reactions is called as redox couple. The combination of these two reactions is called as what? Redox couple. So the combination of oxidation half reaction and reduction half reaction is called as redox couple. Redox couple. And these two electrodes, the electrode at which oxidation half reaction takes place is called as oxidation half cell. It is called as oxidation half cell. This is reduction half cell. Oxidation half cell and reduction half cell. And these two are collectively called as redox couple. These two are called as redox couple. At this anode, oxidation takes place and the electron lost by the zinc are flowed towards cathode. Means the electron flow in this direction. This is the direction of flow of electrons. In the opposite direction, what happens? Our electric current will flow. Electric current will flow. So this is about the half cells and half cell reaction. Oxidation half reaction and reduction half reaction. At anode, oxidation half reaction takes place. It is called as oxidation half cell. At cathode, reduction half reaction takes place. So it is called as reduction half cell. And these two cells are half cells, and these two are collectively called as redox couple. These two are called as redox couple. And I think you have observed that the anode is given as negative here and the cathode is given as positive. So what does this negative and positive indicates? So let us come to understand the what about the signs. See here, let us consider the one of the two cells. I will take, generally I will consider one electrode, the setup for a electrode. I will take a setup for electrode. What do you mean by electrode? When a metal is placed in the solution of its own ions is called as electrode. So I will consider this is 1 our electrode. See here, let us consider this is our zinc electrode. I will take, for example, I will take it as zinc electrode. Zinc rod is dipped in the zinc sulfate solution, isn't it? This zinc sulfate solution consists of Zn2 plus ions. Zinc sulfate solution consists of Zn2 plus ions. And zinc rod is made up of what? The zinc. Let us consider this is our zinc rod. Zinc rod is made up of large number of zinc atoms. The large number of zinc atoms are present on the zinc strip, zinc electrode, and here the large number of Zn2 plus ions are there in the solution. Okay. Before studying this, I will give an example. So now it is a corona pandemic days. Nowadays what happens? The people who are sitting in the home, they are feeling that we want to go out and we want to the roam here and there. They are feeling like that, they are thinking like that, and the government officials which are working in the hospitals and the police stations, they are thinking that so this is too bad condition, just we will get time and we'll take rest. Just they want to take rest, and the people who are sitting in the home, they want to go out. The people who are working outside, they want to go to home and they want to take rest, and the persons who are taking rest, too much rest, they want to go out. So here the very same tendency, the people who are sitting in the home, they have tendency to go out. The people who are working outside, they have tendency to go to home and take rest. The very same thing happen here. ಸೊ ಈಗ ಕರೋನಾ ಸಲುವಾಗಿ ಏನಾಗಿದೆ ಅಂದರೆ ಮನೇಲಿರೋರೆಲ್ಲ ಏನು ಮಾಡ್ತಾರೆ ಅಂತಂದ್ರೆ ಮನೇಲಿ ಇದ್ದು ಬೇಜಾರಾಗಿ ಏನು ಮಾಡ್ತಾರೆ ಅಂತಂದ್ರೆ ಹೊರಗಡೆ ಹೋಗಬೇಕು, ಎಲ್ಲ ಸುತ್ತಾಡ್ಕೊಂಡು ಬರಬೇಕು ಅಂತ ಥಿಂಕ್ ಮಾಡ್ತಿರ್ತಾರೆ. ಅದೇ ರೀತಿ ಹೊರಗಡೆ ಏನು ಕೆಲಸ ಮಾಡ್ತಿದ್ದಾರಲ್ಲ ಈಗ ನಮ್ಮ ಸಲುವಾಗಿ ಹಾಸ್ಪಿಟಲಲ್ಲಿ ಅಥವಾ ಪೊಲೀಸ್ ಸ್ಟೇಷನಲ್ಲಿ ಅಥವಾ ಇಲ್ಲಿ CMC ಕೆಲಸ ಮಾಡ್ತಾರಲ್ಲ, ಅವರೆಲ್ಲ ಹೆಂಗೆ ಥಿಂಕ್ ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ ವರ್ಕ್ ಮಾಡಿ ಜಾಸ್ತಿ ಆಗಿಬಿಟ್ಟಿದೆ, ವಿ ಆರ್ ಸ್ಯಾಚುರೇಟೆಡ್, ನಾವು ಸ್ವಲ್ಪ ರೆಸ್ಟ್ ತೊಗೋಬೇಕಂತ ಅವ್ರು ಥಿಂಕ್ ಮಾಡ್ತಾರೆ. ವರ್ಕ್ ಮಾಡೋರು ರೆಸ್ಟ್ ತೊಗೋಬೇಕಂತ ಥಿಂಕ್ ಮಾಡ್ತಿದ್ದಾರೆ. ಸೊ ರೆಸ್ಟಲ್ಲಿರೋರಿಗೆ ಏನು ಥಿಂಕ್ ಮಾಡ್ತಾರೆ ಅಂತಂದರೆ ನಾವು ಹೊರಗಡೆ ಹೋಗಬೇಕು, ಸ್ವಲ್ಪ ಸುತ್ತಾಡ್ಕೊಂಡು ಬರಬೇಕು ಅಂತ ಥಿಂಕ್ ಮಾಡ್ತಿದ್ದಾರೆ. ದ ವೆರಿ ಸೇಮ್ ಥಿಂಗ್ ಹ್ಯಾಪನ್ಸ್ ಹಿಯರ್. I will connect this present situation to our electrode. See here, the zinc atoms which are present on the electrode, they are like people who are taking rest at their homes, isn't it? The atoms which are present on the zinc electrode, these atoms have tendency to go out. Go out means what? The atoms which are present on the electrode, they try to go out from the metal. Means the atoms which are present on the zinc, they come out as ions. They try to come out as ions. If they come out as ions, what happens? Zinc must be converted into zinc ion. Zinc converted into zinc ion. If it is converted into ion, it must lose 2 of its electrons. The lost electrons are left on the electrode, hence the electrode becomes negative in charge, isn't it? And the ions which are present in the solution, they also have a tendency. Which type of tendency they have? They want to go to home. Means they are already moving in the solution and they are saturated, so they try to get rest at their homes. Means they try to go to the electrode and they try to deposit on the electrode. This is our ion. If the ion is deposited, it must become a atom. Means Zn2 plus. If it gets 2 electrons, it becomes Zn. Means the ions present in the solution try to get reduced and they try to saturate or deposit it on the electrode, and the atoms present on the electrode, they try to come out. See here, ಇಲ್ಲಿ ಜಿಂಕ್ ಸ್ಟ್ರಿಪ್ ಮೇಲೆ ಏನಿರುತ್ತೋ ಅಂತಂದ್ರೆ ಜಿಂಕ್ ಅಟಮ್ಸ್ ಇರ್ತಾವೆ. ಈ ಜಿಂಕ್ ಅಟಮ್ಸ್ ಯಾವ ತರ ಅಂತಂದ್ರೆ ಈಗ ಏನು ನಾವೆಲ್ಲ ಮನೇಲಿ ಕುಂತಿದೀವಲ್ಲ ಆ ತರ ಇವೆಲ್ಲ ಏನು ಮಾಡ್ತಾವ ಅಂತಂದ್ರೆ ಹೊರಗಡೆ ಹೋಗಬೇಕು, ಇಲ್ಲಿ ಸೊಲ್ಯೂಷನ್ದಾಗ ಎಲ್ಲ ಕಡೆ ತಿರ್ಗಾಡಬೇಕು, ಮಜಾ ಇರುತ್ತೆ, ಮಜಾ ಮಾಡಬೇಕು ಅಂತ ಟ್ರೈ ಮಾಡ್ತಾವ. ಅದೇ ರೀತಿ ಏನು ಮಾಡ್ತಾವ ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ಸೊಲ್ಯೂಷನ್ದಾಗ ಇರ್ತಕ್ಕಂಥ Zn2 ಪ್ಲಸ್ ಅಯಾನ್ಸ್ ಇವೇನು ಮಾಡ್ತಾವ ಅಂತಂದ್ರೆ ಇವು ನಾನು ಹೋಗಿ ರೆಸ್ಟ್ ತಗೋಬೇಕು, ನಮ್ಮ ಮನೇಲಿ ಏನು ಮಾಡಬೇಕು, ರೆಸ್ಟ್ ತಗೋಬೇಕು, ಹೊರಗಡೆ ಎಲ್ಲ ಕೆಲಸ ಮಾಡ್ತಿರ್ತವೆ, ಮೀನ್ಸ್ ತಿರ್ಗಾಡ್ತಿರ್ತವೆಲ್ಲ, ಇವೇನು ಮಾಡ್ತಾವ ಅಂತಂದ್ರೆ ದೇ ಟ್ರೈ ಟು ಗೆಟ್ ಡೆಪಾಸಿಟೆಡ್ ಆನ್ ದಿ ಜಿಂಕ್ ಸ್ಟ್ರಿಪ್. ಆ ಸ್ಟ್ರಿಪ್ ಮೇಲೆ ಡೆಪಾಸಿಟ್ ಆಗಬೇಕಂತವು ಟ್ರೈ ಮಾಡ್ತಾವೆ. ಹೌದಾ? ಸಿಯರ್ ಈ ಜಿಂಕ್ ಅಟಮ್ ಜಿಂಕ್ ಅಯಾನ್ ಆಯಿತು ಅಂತಂದ್ರೆ ಯಾವ ರಿಯಾಕ್ಷನ್ ಇದು? ಲಾಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್. ಇಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಆಕ್ಸಿಡೇಷನ್. Here the gain of electron is nothing but reduction. ಇಲ್ಲಿ ಜಿಂಕ್ ಮೇಲ್ಗಡೆ ಇರುವಂತ ಅಟಮ್ ಏನು ಮಾಡ್ತಾವ ಅಂತಂದ್ರೆ they try to oxidize themselves and these try to reduce themselves. ಇವು ಆಕ್ಸಿಡೈಸ್ ಆದ ಕೂಡಲೇ ಏನಾಗುತ್ತೆ ನಮಗೆ? when the zinc atoms are oxidized, they lose their electrons. The lost electron from the zinc atoms retained at the zinc strip. ಇಲ್ಲಿಂದ ಜಿಂಕ್ ಅಟಮ್ ಹೊರಗಡೆ ಬಂತು ಅಂತಂದ್ರೆ ಅದು ಯಾವ ತರ ಬರುತ್ತೆ? Zn2